it has the potential to save 1% of the world's CO2 emissions. And I have battled both with my own money and with my energy and against, you know, all these barriers that you face. These are market access barriers, or these might be barriers of your internal team getting frustrated because you expected to make money after 2 or 3 years, but it takes you 5 or 6, or maybe you never get into that position till you're actually profitable. And you have to adjust all the time, and you need to pump in more money.
And with branding, if you don't have something already established, like you're talking about stuff's been around for 1700, there's a big struggle for you now to go through and find out how does this technology work, and make it more obviously efficient, and then refine that technology so you can get it to a stage where it can compete with the big boys.
So that's been an exciting but challenging journey, but we're now coming from a position of stabilization and strength. Our products have commercially been proven in the marketplace, and we are ready to take the next level. And we have some products where people are amazed, like nothing else like that exists in the world. We have products that are temperature resistant, 1200 Celsius, extremely abrasion resistant, extreme adhesion on concrete and steel, and virtually completely chemically resistant in aggressive acids environment, even superior than any epoxy can deliver. And those are the areas where people are starting to pay us very good money because we're solving problems. But I would like to solve the problem of you know, CO2 emission reduction in the building industry through especially those countries that are experiencing massive growth. And I'm looking at China, India, South Africa, Brazil, Indonesia, where you have a lot of those waste materials, and where you have strategic pockets. We wouldn't even need to hurt the established cement companies. What's the point in investing 1, 2 or 3 billion, I'm not sure how much a cement plant will cost, in areas where you have enough waste material to deliver the concrete needs of the growing industry by a low carbon footprint, high performance concrete, rather than investing a couple of billion into gigantic CO2 manufacturing cement kilns that you don't actually need.
That's why I want to talk a little bit more about this. A lot of people don't look at the actual energy cost. Catalytic converters is a good example. With that a lot of people are putting catalytic converters thinking they're helping the environment. No, the amount of pollution and chemicals that are released is horrible. So look at the flexible solar panels, for instance, as well. But can we, this is an overlooked fact, society wastes so much energy in the production, and also these chemicals and pollutions are released. So how is this factored in with your business? Obviously you're using waste products and using that to make it more sustainable. But do you include the energy cost, how much energy is going into producing these items?
On the solar panels, for the company that I am a board member of, Solexcel, it's as well an innovation technology. I'm quite careful with which companies I get involved in and technologies, because I have that goal of massive CO2 reduction. And that was the first question I asked them. How long does it take your cells and subsequent panels to recover the energy that was put into the manufacturing of the cells? And the second generation of Solexcel will be about 8 months, less than a year, which is an extremely good figure. That means after 8 months of operation, they'll be carbon positive. And there are no nasty heavy metals involved in the actual cell production either. That's an important thing as well, because some solar cells at the end of life, they might be considered hazardous materials because of the, I mean, any solar cell manufacturing process has got certain environmental impacts because you are dealing with semiconductor type manufacturing processes. So, you know, there's likely some sewing, some etching and other stuff, but we will have a gas deposition technology where we will have close to zero waste. And that way we are reducing the cost of production as well.
And it depends on the country, because in Australia there's a law passed where we can't use toxic materials in the building of electronics, where if you go to some countries like China or India, that's not the case. They don't have laws like that, where they've made it, where it's considered e-waste. And that's one thing where a lot of people don't understand about solar panels, for instance. There is a lot of negative effects on the environment. And the average life of a solar panel is at least 25 years plus. So if you're talking about 8 months before it becomes carbon positive, that's amazing. We have over 24 years where it's doing something positive for the environment.
Yeah, definitely. And looking at the first example, the green concrete, what people often measure is the embodied energy of a building envelope. But in the context of concrete, it's not an accurate reflection of the total environmental impact. Because the embodied energy that you would calculate to manufacture it would be the fuel-related energy to get it up to 1400 Celsius. It doesn't actually capture the CO2 emission that you're releasing by decarbonizing the limestone.
Right.
Because there's CO2 embodied in the material and you're releasing it. So it's an impact that's on top of the energy-related impact.
So you have a double footprint.
Yes.
So, right. Actually, yeah, that's we wanted to ask you that question that how do you foresee green materials evolving in the future, working in harmony with nature and reducing footprint? So how do you see this evolving?
Yeah. Obviously, we have to work on two levels. One level is technological innovation that makes use of waste material to replace manufactured stuff that has a heavy carbon footprint, to have a double benefit of waste reduction and replacement of carbon-intense materials. And we need to shift back to natural materials as much as possible.
Right.
I mean, I'm an advocate, for example, when it comes to building materials, of bamboo and other natural materials. Bamboo is amazing. Grows very fast, it hardly needs any water, it absorbs loads of carbon dioxide, and it is a very strong structural material. And if you look at some of the most iconic buildings, I mean in Bali we all have heard of the eco school, it's all made from bamboo. And traditional house building was using bamboo or other natural material, was using natural material for the roof.
I was going to say, even the scaffolding, I went to Bali in 2012, and that was the first thing I pointed out to my friends. I said, we're at home, we do metal everywhere. There they had bamboo, and then they took that down and then replaced it with the actual structure.
I mean, even in science and what we are doing, the Scimeta project, it's actually about returning back to nature or the natural flow of things. So I just want to ask you, in terms of the community in Asia, so for the Lohas, Asia, for example, how do you see the community here evolving, or where do you see the Lohas community in Asia going?
It's growing. It's definitely on the move towards a stronger brigade, but it's still a minority. We don't yet have a mass movement of people that actually say, I buy green. I can give you an example, quite a shocking example, but a true one. I was training some of the members of a green directory, people who were selling green products in Malaysia. And on the second day I challenged them, so how many of you guys are actually buying green in your own lives?
Living green.
Yeah, and only one hand went up. And I was like, I was a bit, I was whacking it a little bit and saying, how can you guys expect or even complain that the market is not grabbing all your products if you yourself don't even practice it? So, so we need to go back to the basics. A lot of people will say, I buy green, but at the end of the day, it's all about convenience. Southeast Asia, we're still in a lot of countries between developing and developed. So in Malaysia, cherry makan, where do I get my money from, is the priority, understandably. But the system is giving people the impression that it's cheap to consume resources, because a lot of resource consumption is subsidized. People don't realize that to get water to your house costs a lot of money. There's a water pipe being built from Pahang to Selangor. Hardly anyone knows that an originally 4.5 billion budgeted project, latest estimate 9 billion, will cost every Malaysian taxpayer maybe a couple of hundred ringgit. So the true cost of water is huge, but people don't necessarily realize. They complain organic food expensive, but the fact that the cost of producing chemically containing Cameron Highland vegetables, in terms of destroying the soil, destroying the water, destroying your health, and the impact on society of having to pay for rectifying that, is going to be much bigger than the money we're saving by making them cheap. So the true cost is different than what people are actually perceiving. And what people are perceiving is green is expensive and non-green is cheap. That's why most people say, I cannot afford it. But my message is, the fact that I'm living green means I have more money in my pocket than you. Why? My electricity bill, since I lived in Malaysia since more than 9 years, has always been plus minus 30 ringgit a month. Only when I had somebody else staying with me, then it went up.
Leaving lights on, doing this and that. But it's interesting when you're talking about the food, because that's one thing in Australia that we take very seriously. And a lot of people will support green, because I know just the imprint. You look at it in America, there's a lot of places that are dust bowls. They've destroyed the soil, they've put in all these chemicals, you're eating irradiated food, and basically people there are happy to pay a little bit more money, because you know that what they're doing is they're using natural materials, they're not using fertilizers, they're using eco things, putting in certain bacteria or certain species of insect to eradicate some of these other problems, instead of just throwing chemicals at it, and throwing money at it too. The amount of money and resources that you're putting into other companies to do this, it's counterproductive, and you're leaving a huge footprint.
But I think here the majority of people that buy organic food do it for health reasons. The health argument is more direct, more personal. Whereas saving the planet, or actually saving the human species, because the planet will survive, but the human species might be partially wiped out or whatever if we overstretch the carrying capacity of the planet. So that is less immediate. So and people's focus is more my survival, my family, understandably so. That is how we humans are maybe.
Here's the question. Do they ever look about the future parts of the family? Because people are only looking in the here and now. And one thing which a lot of people are trying to push forward now is, why don't you have a look at, not you, but look at your grandchild. And that's one thing that a lot of people aren't paying attention to, and we're using that one now for the coal seam gas in Australia. Because you can see if people wreck all the water supplies, what are people going to drink in 20 years' time? Because all the water has gone to these big companies that have been polluted and put all these gases through everything. So maybe that's something that Lohas and people like that should be looking at. Not the now, but look at the future generations. Do you care what happens in the future?
That's what I ask people, but then I observe that the focus of people is the here and now. The focus of people is, how can I help my family in the short term rather than the long term? And it's too abstract. What counts for people here is, how can I maximize my money making and return on investment at whatever environmental cost to make sure my family can live well.